Hello, everyone. Welcome back. So, today I'm going to be talking about exponential functions. Today, we're mostly going to be talking about specifically integer exponents and integer exponent laws and how to use those. So, let's get into it. Okay, so let's first discuss the exponent laws, not just what they are, but why they are true, because it's easier to remember them if we understand why they are true, especially if memorization isn't your strong suit. Being able to understand why they are the way they are, if you forget them, you'll be able to quickly figure out, oh, right, the exponent law says this because this is true. So the first exponent law is let's use x to the power of m times x to the power of n is equal to x to the power of m plus n. So basically, long story short, in just English terms here, this says that if we have two exponents that have the same base and we multiply them together, we can add the exponents. Okay, so for example, if we have 2 to the power of 3 times 2 to the power of 4. This is 2 to the power of 3 plus 4, which is 2 to the power of 7, right? Which I'm not sure what that is, but that's not the point. The point is we are able to add together the exponents because they are two exponents of the same base. Now, why is this true? How can we do this? Well, if we think about it, we have n, x times x times x, blah, 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 right? We have this m times, and then times, and then x plus times x times x times, blah, blah, blah. We have this n times, right? So how many times total are we multiplying x, right? Because that's what an exponent is. It's just the same, it's the base being multiplied over and over and over, however many times the exponent says. X squared is x times x cubed is x times x times x, etc., right? So in this case, if we have x multiplied m times, and then also we're multiplying n times on top of that, this is equal to x to the m plus n. Now, for similar reasons, I won't go into as much detail about number 2 because it's very much the same logic. It states that if we have x to the m over x to the n, this is equal to x to the m minus n. And it's kind of the same deal, right? If we have, m times on the top, x multiplied m times, and then x multiplied n times, whichever number is lesser, we can cancel out, right? Like let's say we have x to the 4 over x to the 3. We could use the exponent law to say this is x or x to the 1. We could also just do it out and say x times x times x times x over x times x times x, and we could cancel out these 3 with these 3 here and just be left with x if we think about it that way. So it's very reasoning wise, it's very similar, except we subtract because we're canceling out when we have some on the top and some on the bottom, whereas in the first case, for law number 1, we're just adding even more, essentially. Okay, let's look at law number 3. Law number 3 states that x to the m n is equal to x to the m times n. Okay, now why is this true? Well, let's think about it. We have x to the m n. Well, this is equal to x times blah, 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 m times, right? To the n, right? Which this is equal to x times blah, 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 m times. And then this is going to repeat again. And all of these to however many it is going to be n times, right? So we take this and we say, okay, x to the power of m, and then all of those n, right? And if we had a third variable, all those to that variable. And so here we're multiplying as opposed to just adding in this case, because we're taking one and then we're also taking that number to the exponent of our next thing, right? So this one is going to happen n times after we've already taken each thing to the exponent of m already. So those are our main exponent laws. There are more, but those are the ones I'm going to talk about for now. Now let's see if we can use these exponent laws to express each of the following as a single power. I know this says integer exponent homework. We're actually not going to do it as homework. I'm going to use this to demonstrate some class things. Now, with that being said, I also, I'm not going to complete all of these during this video. I'm going to complete a few of each type, and I will leave some of these as suggested practice for you guys to try as well. Okay, so let's write each of these as a single power. Well, let's see. The first one is 5 to the power of 6 times 5 to the power of 8. Well, as we know, we can add up those exponents and get 14. So this is 5 to the 14. What about the second one? Same logic. We take negative 4, we add up the 4 in this 12, and we get power of 16. Over here we subtract. We get 3 to the power of 3. Over here we subtract again, right? And in this case, 2 is the same as 2 to the 1, so 10 minus 1 is 9, so this is 2 to the 9. Then here for e, we multiply, right? We have 8 cubed, and then whatever that number is, we have that number to the power of 12 after we've already cubed. So this is going to be multiplication of our exponents, and this is going to be 8 to the 36. 8 to the 36. Now what about this one? Here we have negative 4 to the power of 3, and then that to the power of negative 2. So again, we are going to multiply our exponents and get negative 4 to the power of negative 6. Okay, for g, 4 to the power of 30. Again, we're multiplying our exponents. H, okay, we have division here, so therefore we're subtracting our exponents. We're going to get 2 to the power of 8. Okay, for 7, or for I, we have 7 to the power of 10 over 7 to the power of 8, so we subtract, right? 7 to the second power. And then here we have x to the power of 7, right? Because we're subtracting. We're doing 15 minus 8 based on that second law we learned. For k, we're going to multiply the exponents and get 9 to the power of 15. And then for L, we are going to have 4 over 7 to the power of 5 times 4 over 7 to the power of 8, which is 4 over 7. So same base, the power of 13, right? Because we add up the exponents. All right, so that's our first thing done. All right, and the great thing about this one is all we have to do is know those 3 exponent laws. With the knowledge of those 3 exponent laws, we were able to very quickly and easily identify how to express the following in a single power. And it may not have been obvious without those rules, but the point of this exercise was to practice using those rules, to get some practice in to understand those rules. Now here it says, write as a single power or expression for all of these ones. And for this one, I think we're going to need some more room. So I'm actually going to copy all of this. And we're going to put it on a new graph paper. Beautiful. Okay, let's make it a little bit bigger. Okay, no, that's good. All right, so for A, here we're going to have to use 2 different laws for A. So we have 6 to the power of 6 times 6 to the power of 11 over 6 to the power of 2. So first, I'm going to deal with the top, and then we'll deal with the bottom. So on the top, we have 6 to the 6 times 6 to the 11. And as we know, we can add up those exponents and get 17. So 6 to the power of 17 over 6 squared. And then now we have division. We can subtract the powers, right? So that's going to be 6 to the power of 15. So this is the same as the last exercise, except we may have to use 2, if not all 3 of those laws in the same question in order to find the answer. So in that sense, these are more challenging than the previous ones. Okay, let's try B. B is 7 to the 6 3 times 7 over 7 to the 4. Okay, so first thing I need to do is deal with is deal with this, the purple part. And to do that, I'm going to multiply the exponents. So we're going to get 7 to the 18 times 7, which 7 is same as 7 to the 1 over 7 to the 4th. Okay, then we're going to add up our exponents 18 and 1 because we're multiplying two of the same base. So 7 to the power of 19 over 7 to the 4. And this is equal to 7 to the power of 15. So that's our final answer. All right, so I'm actually going to skip C and D, and I encourage you guys to try C and D. I'll highlight them as homework. I'm going to move on to what we would do for E and perhaps F. Okay, so let's do E. Let's do E here next. So E says 6 to the 5 times 6 to the 2 to the power of 3. So first I'm going to add my two exponents of 5 and 2. So that's going to give me 6 to the 7 to the power of 3, which is equal to 6 to the power of 21 when we multiply the 7 and the 3. Okay, let's do F. F is 2x to the 5 y times 7x to the 6 y squared. So for this one, my first step is going to be to multiply the 2 and the 7. So 2 times 7 is 14, so we'll just put 14 there. Then we have x to the power of 5 times x to the power of 6, which if we add those exponents, we follow that first law, we're going to get x to the power of 11. Then for y, we have y to the power of 1 times y to the power of 2, and that is y cubed. And so that's our answer. Now G is very similar, so I'll leave that one for homework too. And H and I are similar, so I'll leave I as homework and we'll go through H together here. Okay, so H says x to the 4 times y to the 12 over x times y to the 7. Okay, so let's see. X to the 4 over x would be x cubed, right? Because x is the same as x to the power of 1. And then y to the 12 over y to the 7 is just y to the 12 subtract 7, which is 5. So y to the power of 5, and that's our final answer there. Okay, so there's number 2, or at least most of number 2. I guess I did 1, 2, 3, 4, 5 of them, and I left 4 for practice. So please do practice those. That's going to be part of the homework today. Okay. The next one says to simplify these expressions. Now, these expressions are quite similar to what we had done previously, but they have a key difference, a key distinction. So I am going to do A, C, and E, and then I'll leave 2 as homework. I'll leave these 2 as homework for everyone to go ahead and try, and then we will do number 4 afterwards. Okay, so 2x to the power of 5. So it may seem obvious it's x to the 5. That's true. But we also need to take 2 to the exponent 5. So this is the same thing as 2 to the exponent 5, x to the exponent 5, and 2 to the 5th power is, I believe it's 32. Let me just check that. 4 times 4, 16. Yes, 32. So it's 32x to the 5. Okay, then for C, we have everything to the power of 3, right? So negative 3 to the power of 3 is negative 27. X to the power of 4 to the power of 3 is going to be x to the power of 12, right? 4 times 3, 12. And then y to the power of 2, and take that, all those y squares to the power of 3, we get y to the power of 6. Okay, and what about for E? Here we have 5 cubed, which 5 cubed is 125. Is that true? Yes, that is true. X cubed is, x cubed. And x to the 4 cubed is y to the 4 times 3, which is y to the power of 12. So voila, we've done it. Okay. let's do this one. I'm actually just going to pick half of this. We will do all of these for homework, and I will go through all of these other ones, A, B, E, F, I, and J in the group. Okay. All right, so let's start with 5 to the power of 0. Well, there's actually a rule that says that anything to the power of 0 is equal to 1. So if you didn't know that, now you know that. Anything to the power of 0 equals 1. And in some cases, that could even be considered like an exponent law, an exponent identity. I didn't include it here. It only applies in very specific situations, but it is something important to note. And I guess by extension of that, x to the power of 0 also is 1, and negative 1,000 to the power of 0 also equals 1. So actually, I guess those first three weren't too hard. And then we have b. We have 4 over 3 squared. So this is the same as 4 squared over 3 squared, which is equal to 16 over 9. Here we have 1/3 to the negative 2. Well, this is the same as 3 squared, right? Because if we recall from last year, a negative exponent flips our sign, right? So 1/3 becomes 3, or 3 becomes 1/3, right? We take the reciprocal. And the reciprocal of 1/3 is just 3. And because we took the reciprocal, we can get rid of the negative sign because that was the negative sign's meaning. Now that we have fulfilled what the negative sign wants, we don't need the negative sign any longer. And then 3 squared, well, that's just going to be 9. So we can just write 9. Similar with this one, here we have 2/3, the negative 2. So this is the same as 3 over 2 squared, right? I flipped them again because we have a negative sign. As soon as you see a negative sign, you flip it, right? So do recall that rule from previous. And then we have 3 squared over 2 squared, which is 9 over 4, and that's the final answer. All right, so for homework, the suggested problems from this integer exponent homework I'd urge you to do. So that includes 3, B, and D, and then half of number 4 I left as homework as well, and then also 4 of the questions from part 2 as well. So just go ahead and give those a try, and we will see you later. Bye, everyone.